Hello everyone, I am back with the parallel circuit calculations. So with this one, we are going to be looking at how you come up with your numbers and do your calculations for a circuit that is in parallel, or a parallel circuit. Okay? So I just want to get everything straightened out here before we start. Okay, so here we go. So last time we did series circuits, which were on my back side here, which look like this. These are series circuits. Now we're going to be doing our circuit calculations for these types of circuits, which hopefully you already can tell are parallel. Okay, so if we remember, the word parallel means to be next to. So as we can see that all of our components in here are side by side or next to each other, which means they are in parallel. Okay. So when you're writing down the type of circuit, that indeed is a parallel circuit. And we have to write down our rules for our parallel circuits. Okay. So remember, each of our rules deals with a specific part of our circuit, whether it's voltage, current, or resistance. So what we have to do is write those down. Our first one is that your voltage is the same in each branch and that will equal the total. The total voltage. And in many cases, that's the voltage leading to it from the main, like the main branch. This is important to distinguish because it can be different depending on if it is a simple parallel circuit or if you're dealing with combination circuits, okay? The second one is that the sum of your branch currents equals your total current. So I didn't go over each of these separate, but voltage is the same in each branch, which means that whatever the total is here, that's what your voltage here through your other resistors will be. Okay. Whereas 2, the sum of your branch currents will equal the total current. This means that your different currents here, current 1, 2, and 3, will add up to your total current at the bottom. Okay? And lastly, our third rule is that resistance is smaller than like a sum, and instead follows an equation. And that equation, if you remember, is the crazy looking 1 over 1R1 plus 1 over R2, 1 over R3. Okay. This equation, I will explain how to use it in a little bit. And I will also show you an alternative way to get your R rather than using this equation. There's 2 ways to get your R as long as if you know Ohm's law. Okay. So first off, let's take a look at our circuit diagram here and see if we can't fill anything out on our chart down below. So first off, you can look and see that you have a 9-volt battery. That's our total voltage, 9 volts. And then we have resistors 1, 2, and 3. Resistor 1, it says, is 90 ohms. Resistor 2 said it is 45 ohms. And R3 says it is 180 ohms. Okay. We don't know anything about the current for right now, and we don't know anything else other than those 4 numbers. So let's stop and look at our rules here to see if we can't fill anything else out. So rule 1 says that your voltage is the same in each branch, and that should equal the total voltage going into it from the main wire. This means that our main wire holds 9 volts, and that is what is going to each of those. So each of these here is 9 volts. Nice and easy, right? Now, we can do one of 2 things from here. We can find out, we can use our equation, resistance, because if we're looking for resistance here in this box, we can use this equation right away to find R. Or notice that in each of these we have, in each of our branches, we have 2 of the 3 like main things that we need. All right, which means that we can go about filling the rest of these out in 1 of 2 ways. The first way is that we can use Ohm's law to determine the current in each of these branches, and then using our second rule, sum of all of your branch currents equals your total current. Once we find the current here, we can add it to the total there. Okay. And once we find that, we can use these 2 values to find the total resistance. Okay. We do not always need to use this equation. If you're a whiz with fractions, you can use this equation really quickly to find R. Okay. However, you do not always need to use this. You can use Ohm's law only to find what you need. Okay? So, let's take a look at that here. All right. So first I'm going to show you how we solve for R using Ohm's law to find our currents first. So this method is going to take a lot more calculations, but the calculations are easier because we're already using Ohm's law to do it. Okay, after that I will show you how to find R without using Ohm's law to find our currents first. All right. So I'm going to scoot this down and use my workspace here. I'll do this with a brown pencil. So the first way we do this, so we use Ohm's law to find the current for all of these. And if we remember, this is our triangle, and our equation that we normally see is I equals V over R. Okay, so I, this is what we're looking for, is V over R according to our triangle. So we have both V and R. So for R1, so for our first resistor, we're looking for I, and V over R which is 9 volts over 90 ohms. So if I take out my phone and do my calculations on my calculator, 9 divided by 90 comes out to 0.1. That's our first current. Let's do R2. And that one is 9 volts as well over 45 ohms. 9 divided by 45 is 0.2 amps. And then R3 for the current is going to be 9 volts over 118 ohms. And that gets us 0.05 amps. So then we can put all of those in here. And if we look at our rule that talks about currents, which is the sum of all your branches equals your total current. So if we take a look at all of that just means if we take all 3 of these, add them together, it's going to equal the total. So 0.1 plus 0.2 plus 0.05 is 0.35 amps for our total current. Okay. From there, you can use Ohm's law to find your resistance because you have both your volts and your current. You have 2 of the 3 that are necessary. So when you find the resistance, you just have to find total resistance, so RT. And we're looking to find R, so we cover up R and we see that R equals V over I. And so V is 9 volts total, and your current is 0.35, so we divide that by 0.35 amps. And that gets us 25.7. And that's in ohms. Okay. So that's what would go in here in your total resistance. So as you can see, we did a total of like 4 calculations to do that. We found this one, this one, this one with Ohm's law. And then we used our rule here to figure out the total current, and then used Ohm's law again to find your resistance. So as you can see, you did not need to use this equation to find this resistance. Okay. Okay. Next, I'm going to show you how you find the resistance using this equation. Sorry about the ding ding, everybody. I'm popular today. So I'm going to bring out a separate sheet of paper to do my calculation for my equation here. Okay, I'm going to use black pen for this to show you it's different. So our equation for resistance in a parallel circuit is 1 over 1 over R1 plus 1 over R2 plus 1 over R3, okay, equals your resistance total in a parallel circuit. Okay, let's write down our resistances again. R1 is 90, R2 is 45, and R3 is 118. Okay, right? So how this equation works is actually fairly simple if you know how to add fractions. Right now, we are going to concentrate on the bottom half of the equation only and not worry about that part. Okay? So when we write this, it's basically 1 over 90 plus 1 over 45 plus 1 over 180. However, any of you who remember simple fraction math know that you cannot add these unless the denominator or the bottom number is the same between all of the numbers. So in order to do this addition correctly, we need to make the number on the bottom the same for all of our fractions. And the easiest way to do that is to see if there's a common thing that you can multiply these by to get to. In this case, it will be 180 because it's the largest number. And usually the largest number, you can't go lower than the largest number because 1 over 180 is like, this is a really small number and you can't make it any smaller. So the easiest way to get these two like that one is just to see how many times each number goes into 180. So if I take out my calculator again, how many times does 180 go? How many times does 90 go into 180? You can simply divide 180 by 90 and see that it goes in there 2 times. This means that you just had to times 90, your 1 over 90, each top and bottom by 2, which leaves you with 2 180. That's how you convert this fraction to have 180 as the bottom number, the denominator. Then we convert the 1 to 45. So if we take 180 and divide it by 45, we see that we have to times each up and down by 4. This gets us 4 over 180. And this one, since we started with 180 as our bottom number, it doesn't change. We bring that down. Now you can add these all together with 180 being the bottom number. 2 plus 4 is 6 plus 1 is 7. 180 over 1. So 7 over 180 is your fraction. Okay. So that's what goes down here. But this 1 over 7 over 180 might be confusing to some people. I don't like looking at that. That's gross. What you do with this instead is you flip it upside down. That's basically what this means, is you flip the fraction you get here on its head. And so it's 180 divided by 7. Instead. And if we do that simple math, 180 divided by 7, we see the number that we get for our total resistance is 25.7 ohms. Now hang on now. That's exactly what we got doing this other method. Okay? So I'm showing you that both of these processes work if you want to do Ohm's law, like what we did on this side. or it works with the equation, and this is how you use it. If you are good with fractions and can do this really quickly, I would default to this way to find your resistance in parallel. Remember, this is only in parallel. Okay? If you're not so good at fractions, if this stuff is harder for you, try and use this method. Okay? This method. This method, because this method is easier because you're already using an equation you know, hopefully. Okay? But now that you've filled in all of your blanks, you have finished your problem. You've finished filling in everything that you needed to. Okay? So that is how you do parallel circuit calculations. Remember to keep all three of your rules in mind. So if you ever get stuck anywhere along the way, look back at your rules to see if they can help you. Okay? And obviously, from what you can gather from parallel circuits, is that the hardest one to come up with the number for is your total resistance because of rule number 3. Otherwise, rule 1 and 2 are pretty easy to understand. Okay? So, we've gone over series and parallel circuit diagrams and their calculations. Okay, we did both of these. Next time I'm going to cover how you do combination circuits, whether we get to them or not in class, because I just want you to be, realize that there are combination circuits and there is a way you solve those. Okay? So I'm going to leave you for now. Check back for the next video to see combination circuits. Talk to you later, everybody. Bye.